So this video is part one in your notes. Ultimately, we're going to be talking about velocity. So to be ready for this video, you want to make sure you have a few different things out. You want your problem set and the paper notes from class. You want something to write with, and you want a calculator. We're going to be starting with the notes, going over definitions and a couple of formulas, then we'll move to the problem set. So, as we discussed at the beginning of last class, motion relates to so many things in our everyday lives, and we already have a lot of words that we use to describe motion. The words we'll introduce in these notes are going to build on that and add some physics definitions to things you already say and talk about, like distance and speed and velocity and measurements and things in yards and feet and meters. So just some intro vocabulary of things that we will be discussing in this unit. We'll talk about positions. Positions refer to your specific location, not necessarily a distance. So a distance is a measurement between initial and final positions. Specifically, distance versus displacement. Distance is talking about a measurement of length traveled. This is a little more informal. In physics, we use displacement more. However, we're going to refer to these as sort of the same thing, but we'll talk about their slight differences here. So displacement is probably a new phrase or word for you. Displacement is specifically a measurement between a final and initial position. Okay, so maybe you started out here. You then walked, 5 meters, 5 feet, whatever it may be, and this is where you ended. What's your displacement? Well, it would be that measurement between, let's say, of 5 feet. In this same case, what's your distance? Well, it's the same thing. It's a measurement of your length traveled. It's 5 feet. While here I used feet, the unit we usually use in physics is meters. This is the metric system. Meters we will shorten as little m. 1 meter is roughly 1 yard, which is roughly about 3 feet. So let's take a look and see how displacement and distance can be different in some cases. So let's say this is our route. This was our starting position. We then went along that blue line as the path taken, and this is where we ended. Well, you can see that purple dotted line follows our path taken. Would that be our distance or would that be our displacement? Well, looking at the definitions, that would be a measurement of the total length traveled. That purple would be a measurement of the distance. Now, the distance or the measurement between the starting and ending position, that would be our green displacement. So here's a case where these things, these two measurements, distance and displacement, can be really different. In the video that we watched with the car salesman and Jeff Gordon, the racing around video, the distance was super long, right? They went all over town and did all sorts of jumps and weird things. The displacement, though, the difference between the starting and ending position is actually 0 because they started and ended at the same place. Now, there's a lot of cases like this and like the video where these things can be different. However, usually in our calculations in physics, these will be the same. but I just want you to know they are these kind of different ideas and different vocabulary words to talk about them. So what do we even mean in physics when we say something moves? Well, motion is just when an object travels a distance. However, all motion is relative. And what that means is we only really say that something is moving as compared to something else. If two objects are going the same speed, there is no actual relative motion. This gets into a really fun branch of physics called relativity. And Einstein did a lot of crazy, weird thinking in his mind talking about relativity and a lot of thought experiments thinking about the universe. Because you might say, well, right now, are you moving? Well, you're sitting at a desk watching this video. Okay, so you might say, are you moving? Well, everything in the universe is moving, right? Earth is spinning and traveling at a crazy speed, moving through our galaxy and spinning around the sun. We're moving in many different directions at the same time. However, do you have a speed as you're sitting right there? No, your speed is 0, but you're moving. But are you moving relative to something else? It's just kind of a fun, crazy thought experiment that we do a lot in physics. So let's just think about that with a little bit of a check-in here. So let's say that we are sitting, everyone together in the classroom. Okay, then there are these two cheetahs all running around us at the exact same speed. Let's say they're running at 50 miles an hour around the classroom. We're seated. Are the cheetahs in motion relative to each other? No, because they're going the same speed, 50 miles an hour. Are the cheetahs in motion relative to us? Yes, there is a difference in our motion. They're going 50 miles per hour. We're going 0 miles per hour. Are we in motion relative to each other? No, because we're both going 0. We're both seated in this imaginary scenario. And so A and C, through a physics thought experiment lens, are actually the same. If something is going the same speed, there is no motion. If something is going different, there is. Kind of a weird idea. Physics will push your thought processes and what you think of as normal many times this year. So how do we even measure motion in physics? Okay, this is probably the most important, or one of the most important slides here in these notes. So it's all about speed and velocity. Okay, so first let's talk about how these two things are the same. They both measure how fast, and they both have a standard unit of meters per second. Okay, so if I say that I'm going 5 meters per second, that means every second I'm traveling 5 meters. Okay, so while we say it out loud as meters per second, we write it as m-s. The dash means per, and we just are assuming that M and S stand for meters per second. That's what they stand for in physics. Now, it could be like you often see things in your car, right, as 30 mph. That's saying 30 miles per hour. So standard-wise, though, an M is usually going to mean meters. Sometimes, because Americans are weird and we do things in the non-metric system and the non-standard system, we're talking about miles. But 99% of the time in physics, we want to stay in meters per second. Later on this unit, our next notes will be going into conversions of how we can think about those as converting between them, because they're really kind of different languages. So, but both of those are measuring how fast. Now, they could be speeds or they could be velocities. So let's take a look and think about what the difference there is. So speed is a distance divided by a time. This is slightly different from velocity. Velocity is technically displacement divided by time. But remember, in our calculations, distance and displacement will be the same thing. So what is the main difference between speed and velocity? Well, direction. Okay, direction in physics we indicate by a positive or a negative. So how does that look? Well, it looks like saying that velocity could be positive 5 meters per second or negative 5 meters per second. Now, what does that direction mean? Negative doesn't mean slower. It just means like 5 this way or 5 that way. Positive and negative are opposites. So if someone's going positive 5 and someone's going negative 5, they're going in opposite directions, but they're not going any different speeds. They're both traveling 5 meters every second. They're just traveling this in different directions. Speed, on the other hand, is just going to be 5 meters per second. We're not going to have a positive. We're not going to have a negative. Now, if you think about which one do you think we like more in physics? Well, we like to be more specific. Velocity is what we are mainly going to be using. So things could be positive and things could be negative. And we'll talk more about that in person later. So our first physics formula, let's look at it. This is our first formula for average velocity. Now, let's look at the formula and then we'll look at the notes. So, we use different letters in physics to represent different things. Like in algebra, you use like A, B, X. All those different things can stand for different values, like A is 5 and B is 3 and whatever it may be. So, V, in our case, forever and always, is going to be velocity. We'll have multiple different velocities we might be looking at, and so sometimes we'll have smaller letters below the velocity describing what kind it is. So right now we're looking at V average, or an average velocity. Later in the unit we'll look at like VO, or an original velocity, or VF, or a final velocity. Right now though, we're just looking at average. Okay, we have a couple other letters here that we're going to look at. T is time. Time is always in seconds. So if you look over here, these things that are in parentheses, those are what we call units in physics. So a unit is just saying like, what is the thing that it's measured in? So meters per second is a unit. Seconds is a unit. Meters is a unit. So now X, what's that X thing happening? And for some reason my triangle didn't show up on this doc. So triangle X means displacement, but remember it's kind of the same thing as distance for our calculations. Always measured in meters, which is off my screen annoyingly. What does the triangle mean? Well, it just means the change in displacement or the change in distance, meaning a final minus initial. But really it's just saying triangle X is all one thing and it's referring to how far. And it will be in meters. So if we're going to calculate a velocity of how fast something is going, all we're going to do is we're going to take a distance traveled divided by a time it took. So let's say we went 50 miles in 10 seconds. We'll take the 50 divided by the 10. That will give us our velocity. Notice something about this formula. It does say average. And in math, when you're calculating averages, what you do is like you add up a bunch of stuff and then you divide by the numbers. We're not doing that here. We're not actually calculating any average. So don't think about average velocity as an average of multiple numbers. Think about it as the total velocity over a distance and over a time. So that's average velocity. This is slightly different than instantaneous velocity. So instantaneous velocity is a velocity at a specific moment at an instant in time. So this is what we often assume that we're using in physics. We like this a little bit more. This is what a radar gun that a police might use to say you were going 33 miles in a 20 mile per hour zone or whatever. They are measuring your instantaneous velocity. Now, when you're driving in your car and you see that speedometer change, right? That's also your instantaneous velocity. But if you went on cruise control and for an hour your cruise control was on 30, that's both your instantaneous and your average. If you calculated your average velocity by saying, well, I made it to Idaho Falls in 2 hours, and that was 20 or not 20 miles. What is Idaho Falls? 90 miles, something like that in 2 hours. That's what you would use to calculate your average velocity. So let's watch a little video to help us understand these differences in average and instantaneous, and then we'll do some calculations, and then we will be done. So, as we watch the video, write down any additional notes.
Pretend you were a physics
might
student.
help you.
You were just getting out of class. You were walking home when you remembered that there was a Galaxy Wars marathon on tonight.
Okay.
So you'd do what every physics student would do. Run. You're pretty motivated to get home, so say you start running at 6 meters per second. Maybe it's been a while since the last time you ran, so you have to slow down a little bit to 2 meters per second. When you get a little closer to home, you say, no. Captain Antares wouldn't give up, and I'm not giving up either, and you start running at 8 meters per second, and you make it home just in time for the opening music.
An old video.
These numbers are values of the instantaneous speed. The instantaneous speed is the speed of an object at a particular moment in time. And if you include the direction with that speed, you get the instantaneous velocity. In other words,
so remember, velocity and speed, they vary, or their main difference is that they have direction or not. And in physics, we prefer velocity because it has direction. So that's why you just boxed the arrow. Direction could be with an arrow. Usually, though, it's with a positive or a negative, and that's how we determine and designate that in physics.
8 meters per second to the right was the instantaneous velocity of this person at that particular moment in time. Note that this is different from the average velocity. If your home was 1,000 meters away from school and it took you a total of 200 seconds to get there, your average velocity would be 5 meters per second, which doesn't necessarily equal the instantaneous velocities at particular points on your trip.
Okay, this is a super, super important distinction here I want you guys to note. So in this running example, at one point you were going 6, at 1.2, and at 1.8. Those are all instantaneous velocities in particular moments. Now, we don't know how long you were traveling those different velocities. And so we do know, though, that the total distance you went was 1,000 meters, and you traveled this in 200 seconds. So we can calculate your average velocity with our formula of taking the total distance, 1,000, divided by the total time, 200. And when we divide those two numbers, we get 5. Now notice that 5 is not equal to the 6 or the 2 or the 8. And in fact, if we took the 6 and the 2 and the 8, weird, my calculator is totally off. Sorry, guys. If we took the 6 and the 2 and the 8 and we calculated what the average was at those various points, oops, struggling to, though. Sorry, not at those various points, but over that time. Here we go. Here's a calculator that's working for me. I want to show you here. Calculating the average of those three numbers is not exactly 5. It's a little above. This, what I've done here, is not how we calculate average velocity in physics. Don't do that, okay? What we want to do is what the video did using our formula. It's taking the total distance, 1,000, divided by the total time of 200. It's not always equal to the average of the individual numbers. Also, one thing I want to point out that they did in this example when using this formula is they used meters and they used seconds. A lot of times a problem might tell you like, oh, it took an hour to do that. Well, or 2 minutes. We would then need to change that into seconds. So let's transition here and let's do the 2 examples in your problem set. So you now want to get out your problem set and get out a calculator. Keep those notes out. You'll want to show me those at the beginning of next class. So, velocity. Now, when we're solving physics problems, we're always going to solve them in the same manner and with the same steps. So, what we do is we're going to show all work, include units, and take our time and write out things. So, Johnny walked to school in 200 seconds. 200 seconds is a time. So what I'm going to do is I'm going to write T for time equals 200. Then I'm going to keep going. How fast was he walking if the school was, here's a new number, 950 meters away. So I have to think to myself, 950 meters, that's a distance. Now you might be tempted to write D for distance, but remember that our physics formula used triangle X as displacement or distance. You'll get used to the variables. Okay, now, how fast? Answer in meters per second. We're ultimately solving for the velocity here. Now, it doesn't specifically say average velocity, but I can assume that that's what it's talking about because it's talking about the total distance and the total time. So, now I'm going to look in my notes and think, what physics formula do I have for average velocity? Well, average velocity is distance divided by time, or displacement divided by time. I always write out the formula like that with the letters before I plug in the numbers. The reason I do this is because our formulas are going to start to get more complex over the next few days. So like this, for example, could be a formula that we could look at. Oops, I actually switched those around. This will be a formula that we'll look at. So you can see there's a lot of letters, there's squareds, it's pretty overwhelming. It helps to write out the formula prior. So that's what I did. I wrote out the formula. Now I'm going to plug in the numbers. So my 950 is going to go on top. My 200 on the bottom. When I type into my calculator, 950 divided by 200, I get 4.75. Final answer is in meters per second, and so that's going to be my final answer that I'm going to circle. Okay, number 2, how far can a car go in 1,000 seconds? So same process. That 1,000 seconds is going to be a time. Time, remember, we write in physics as T. So I'm going to write T equals 1,000. Keep going. If it drives with a constant velocity, constant is another way of saying average. So I now have this average velocity of 35 meters per second. So that's what I'm going to write as my V average. And now we're solving for something different here. We're solving for distance. So that's what I'm going to write as my question mark. Now we have the same three variables, so the same formula as we used previously. So even though it feels a little tedious right now, just write out that formula with the letters or the variables so you don't get them mixed up. Look, I even wrote the wrong one. Then we can plug in our numbers. So 35 is our V going over there. Triangle X is what we're solving for, that distance or that displacement in this case. And then time is 1,000. Now, if we want to get triangle X alone, we need to multiply both sides by that 1,000 to get that out of the bottom. Once we do that, the 1,000s cross out, go away, leaving triangle X alone. And then our final answer is just going to be that 35 times 1,000. 35,000. So that's a pretty big number, but this car's going pretty fast, and 1,000 seconds is a fair amount of time. So think, what's our unit here? Well, it's meters because it's a distance. And remember, we just write meters as M.